In the earlier lessons, we saw the reactions of metals with a number of things. Now let's narrow down our learning to one specific case, and that's metals reacting with non-metals. To understand how they react, we just need to know one simple concept, and it's the fact that metals are electropositive in nature. What does that mean? It means that they have the tendency to easily lose electrons and form cations. On the contrary, non-metals are electronegative in nature. And I think you can guess what that means. Yes, they have the tendency to gain electrons and form anions. Clearly, it's a give and take situation here. Metals want to give electrons and non-metals want to take the electrons. A reaction is bound to happen. It's like if you wish to sell your car desperately and there's someone out there who's willing to buy a second-hand one. The transaction is ought to happen. Let's understand this in a bit more detail. Here's a table of electronic configuration of some of the elements. I want you to pause the video and have a good look at this table. What I want you to notice mainly is the number of electrons in the valence shell of these three categories of elements. If you look at the valence shells of the noble gases, we see that they are completely filled. These elements show very little chemical activity. Every element has a tendency to attain a completely filled valence shell. If the valence shell is already filled, then there's no desire to attain a filled valence shell. Now look at the valence shells of metals. Sodium, for instance, has just one electron in its outermost shell. What will it tend to do? It would want to get rid of the outermost electron. And once it loses the electron from its M shell, then its L shell now becomes the outermost shell, which has a stable octet. Now when it loses the electron, there is a net positive charge which gives us a sodium cation Na. Can you guess why? It's because the nucleus will still have 11 protons, but the number of electrons will become 10. Hence, there's a net positive charge. Now look at chlorine, which is a non-metal. It has 7 electrons in its outermost shell and it requires just 1 electron to complete its octet. If it gains an electron, the atom will have a net negative charge as its nucleus still has 17 protons and there will be 18 electrons in the K, L and M shells together. That will give us a chloride anion Cl. You can probably guess what I'm hinting at. Yes, it'll be perfect for sodium and chlorine to react. The electron lost by sodium can easily be taken up by chlorine. The sodium and chloride ions, as we know, are oppositely charged. And hence they attract each other and are held by strong electrostatic forces of attraction to form sodium chloride. The compounds formed by the transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. What's so special about these compounds? Do they have any special properties? Watch the next lesson to know more.